Okay guys, I'm going to do one last video on factoring, and this is going way back to the beginning of the quarter. Okay, this was the very first update we had during the very first week of the Corona apocalypse. And factoring, however, not only does it have some utility or a lot of utility here, but also in Op 6.6, 6.7. Okay, so here's one last time. Let's go over factoring and see if we can't get that. Okay. Thing to do is to look at how many terms we're being asked to factor. Okay, and if it's 4 term, then you can box it or group it. So here we have a 4 term, right? 1, 2, 3, 4. Easiest way to do this is just to put them in order that they show up here in a box. Okay, 1, 2. Keep the sign that they have. All right, I'm going to factor up and left and left. Okay, so here the thing that these have in common is n. Because this is negative, that's going to be negative. I'm going to factor up here. The thing that these have in common is m. There we go. It's positive because this is positive. If I factor this way, these have b in common, and it's negative because this is b. Okay, the one right next to it. If this is negative, this is negative. Here, the thing they have in common is a, and it's positive because this is positive. Okay, it's right next to it. This is negative because right here, the thing adjacent to it is negative. There we go. All right, a minus b, m minus n. There's this factored. Okay, I've split it up into the things that if I multiply it back together, it's going to give me that. Okay, always check your factoring. Multiply it back together, you should get the original polynomial. If you don't, you factored it wrong. All right, let's take one that's a 3 term. Okay, we have 2 different things that could happen. And what we do with it depends upon this thing. Okay, a, the coefficient of the square term. If it's 1, then all I need to be concerned about is the value here. So here's an example, x squared minus 8x plus 7. Notice that I don't have anything but a 1 here. I don't even show it because it's understood. So I'm going to take 7, and I'm looking for pairs, factor pairs. If I multiply them together, I get 7. If I add them together, I get negative 8. In this case, it's got to be negative 1 and negative 7. Negative 1 times negative 7 is positive 7. Negative 1 plus negative 7 is negative 8. These are my factors. So this would factor into x minus 1, x minus 7. Okay, there. This trinomial has been factored. If I FOIL this, I'm going to end up with that. Okay, I can check it. Now, if I have a 3 term, but a is not equal to 1, it's something else, like here, a is equal to 4, there's a bit more complexity. So I have to multiply these 2 things together, 4 and 9. Okay, I have to multiply those things together. I'm going to get 36. So now I'm looking for factor pairs of 36 things. If I multiply them together, I get positive 36. But if I add them together, I get this, negative 12. All right, so in this case, they have to both be negative for that to happen. And when I get down here, there. If I multiply these together, I get positive 36. If I add them together, I get negative 12. This is telling me, okay, these are not the factors themselves. This is telling me how I split this thing up. So now I have a 4-term polynomial. 1, 2, 3, 4. I put it in a box. That's how I do 4-term polynomials. Factor up. Okay, so both of these have 3 in common. 3 is a factor of both of them. And it's negative because this is negative. Factor up here, 2x. Okay, and it's positive. Doesn't matter that this is negative, this is positive. So adjacent to it, it's going to be positive. If I factor this way, 3, and in fact it's negative 3. And if I factor this way, again it is 2x. Notice they are the same. The reason they're the same, so this would factor into 2x minus 3, 2x minus 3. The reason that both of the factors are identical is because this is a perfect square trinomial. happens to be a special case. But there it is, okay? So here, there's that factored 4-term. Here is a 3-term factored where a is equal to 1, and it's very simple. Okay, here I have a 3-term where a is not equal to 1, so I've got to find the factor pairs. That tells me how to split this up, so I have 4 terms. I can box it, and there we go. All right, well, now that brings us down to 2 terms. If I have a sum of squares, then it's prime. Okay, this is not factorable. This is prime. Okay, sum of squares. This is a square, that's a square. All right. They're being added together. If it's a sum, this is prime. All right. If I have a difference of squares, well, if I have a difference of squares, then, well, it's going to be this, it's going to follow this pattern. So let me think of what is the square. A is going to be the square root of this. So a, in this case, is 2x, square root of 9. Okay, so all I did was take the square root of that, square root of that. So b is equal to 3. Okay, so I would put it in that pattern, these two things. So it would be 2x minus 3 times 2x plus 3. Okay, so this factored is that. These are identical. They're equal to one another. If I FOIL this, I'm going to end up right back here. Okay, so sum of squares, prime. Difference of squares, there it is. Okay, it's a special pattern. If I have a sum of cubes, it's going to follow a special pattern, and you have to be able to work with that pattern because you cannot factor this thing by hand. Neither can you do a difference of cubes. All right, so let me take a look at that. So let's figure out then, if I take the cube root, okay, let's find what the cube root of this is. Here we're finding the square root of it, but it's cubed. Okay, so that's going to be x. Okay, so it's the same thing as a. And of course, if I squared it, then I'd have x squared. Okay, the cube root of 27 is 3, and the square of that, of course, would be 9. I need both of those things. So let's look at the pattern. So this is a. Okay, so x plus 3, and then a squared. There it is. A squared is just x squared. And then the product, the negative product of these two things. So 3 times x is 3x, and it's going to be negative, plus finally b squared, okay, plus 9. There. So this factors into this. All right? That is, in this case, is a sum of cubes. If I had a difference of cubes, it's the same thing. I've already got my a and b and my a square and b square there, so I would just fill it in, and the only difference is this minus sign and the plus sign there. So if I fill it in here, I'm going to have x minus 3, same thing here, x squared plus 3x, and then plus 9. Okay, so if I had a difference of cubes there, that's how that would work out. Now let me bring up one other thing. If I had something, for instance, let me find a different marker. If I had something like this, m to the 4th, and you might encounter something like this on the ops, maybe on this op or elsewhere. Okay, one of the things that first thing you always look for is there a greatest common factor that I need to factor out? And the telltale sign is if I have something that's bigger than, well, even if it's cubed, I would look for that first. All right, well, I could take an m squared out of both of these, and I need to do it because otherwise I can't really deal with it. So if I took m squared out of this, then I'd have m squared minus 16. Okay, so you have factored it. You've done one step of the factoring process, but what I'm left with here is a difference of squares. Okay, a difference of squares. So this thing, in the end, would factor. I have to factor it again, and you're going to have a few occasions where you must factor these things again. So if I do, okay, there's m squared, and this is going to be m minus 4, m plus 4, okay, it's following this pattern here. Okay, so this thing factored, here's your intermediate step, pull the greatest common factor out, and then you have a difference of squares and you need to factor that. Okay, so you need to, some of you just, okay, I'm going to attach this video to an email. I'm going to send it to you if you need to rework opportunities 6.3, 6.4. We've got to get some of these things cleared up before the end of the term. And likewise, you need to be able to do this in order really to tackle 6.7, 6.6, 6.7, now op, and all the others. Okay, from there on out, it just assumes that you can factor. Okay, so there it is one last time. So use this for reference. It's open book. Find an example that's like it. So if it's this op, then you're looking for examples in these sections, okay, that match or are similar to the problem that you're working on, and then just use the numbers that you're given in that particular problem. Okay, all right, hit it.